Each system of equations below results in no solutions. Explain the geometrical situation for each case. So our first one is x minus 2y plus 3z is 1, 3x plus y plus 2z is 3, and 4x minus 8y plus 12z equals 7. Now, this plane clearly is not parallel to the first one. Think about where the normal is pointing. But if I multiply this one here by a quarter, I get x minus 2y plus 3z is equal to 7 over 4. Looking at the left-hand sides of these two, we can see they're parallel. So that's going to be two parallel planes with a third plane cutting across. Let's look at part B, I should say. 3x minus 2y plus 3z is 9. Negative 6x plus 4y minus 6z is negative 18. And 3x minus 2y plus 3z is 5. We can see straight away that 1 and 3 are parallel. They have the same left-hand side, but a different right-hand side. If we multiply the middle one by negative half, we get 3x minus 2y plus 3z is equal to 9. So that's the same as this one. So what we've got there is a plane that's listed twice, and then another parallel plane. Let's go for the third one. We've got x plus 2y plus 3z is 13, x plus 3y minus 2z is negative 2, and x plus 4y minus 7z is negative 10. Just looking at the left-hand sides, we can see that none of them is just a multiple of another, and therefore these planes are not parallel. So x plus 2y plus 3z is equal to 13. X plus 3y minus 2z is equal to negative 2. And x plus 4y minus 7z is equal to negative 10. Let's call these equations 1, 2, and 3. Now it's only in the situation where I had no parallel planes that it's worth trying to solve. Notice all of the equations have a single x, so we can start by trying to eliminate x. So let's try doing equation 1, take away equation 2. That means the x's will cancel out, and I've got 2y take away 3y, which is negative y. And then I've got 3z take away negative 2z, so 3z plus 2z plus 5z is equal to 13 take away negative 2, which is 15. Let's call that equation 4. And then if I do equation 2 take away equation 3, the x's again are going to disappear. 3y take away 4y is negative y. Negative 2z take away negative 7z, so that's going to be negative 2z plus 7z, so that's going to be plus 5z. And then I'm going to have negative 2 take away negative 10, so negative 2 add 10, which is 8. And that's equation 5. And we can see that we have this situation where we have the same left-hand side, but different right-hand sides. Those are inconsistent equations, and that is the classic Toblerone box case.